So, hello everyone. This is the next article, which is inheritance and its types. Okay, so let's start. I think all of us might already have a brief understanding of what inheritance is. Inheritance is kind of a parent-child relationship where the child inherits some properties of the parent class. Okay, so now let's read it. So, inheritance is a cornerstone of object oriented programming that facilitates code reuse and establishes a hierarchy relationship between classes, right? Like in a parent and child, we have an hierarchy grandparent, parent, and child. Similarly, we have an hierarchical relationship over here. By inheriting the properties and methods from a parent class, a subclass can extend or override the functionalities, enabling efficient and scalable application development. So this promotes code reuse reduces the redundancy and supports polymorphism, which application which basically helps us in making the applications easier to develop and maintain. So now what are the types of inheritance? First is the single inheritance. In single inheritance, what happens is there is only a single parent and child relationship. From this example, you can see we have a parent class and this is a subclass. So only single class would inherit from the parent class. Okay, so this is like only one level of hierarchy. So a subclass inherits from a single parent class. This is the simplest form of inheritance and it is widely used in Java. We have a class animal. For inheritance, we use the keywords extends. So class dog extends animal. So dog will extend the class animal. We create an object of a dog. Now, since dog has inherited the properties of animals, so through the dog object, we can also call this eat method of the parent class. So dog.eat would also work and print this animal eats food. Okay. So what are the key features? A single subclass derives from one superclass and it promotes simplicity and the clarity in the inheritance hierarchy. Second is the multi-level inheritance. In multi-level inheritance, a class inherits from a parent class and another class further inherits from this child class. So this will form a chain kind of. So the two levels can be grandfather, parent and the child. So similarly, we have an animal. We have a class mammal which will extend the class animal and we have a class dog that will extend the class mammal. So it would be 1, 2, 3, like two levels. So now dog can access the methods of mammal as well as animal. So dog.eat, dog.walk, dog.bark. So this is the animal class. Then we have the mammal class at the second level. And the last level we have the dog class. So it will establish a chain of inheritance and enable deeper specialization of the classes. The third is the hierarchical inheritance. Hierarchical inheritance, multiple subclasses will inherit from a single parent class. So we will have a single parent class and multiple subclasses will inherit from that. So this will allow different classes to share the common properties and behaviors defined in the superclass. So now we have multiple subclass and the parent class is same. For example, a single parent has multiple children. Similarly, we have a single parent class which is class animal and class dog also extends this class and class cat also extends this animal class. So now both these classes can inherit the properties of the animal class. So we can call dog.eat, dog.bark and similarly cat.meow and cat.eat. Got it? So this is the animal class. This is the inheritance symbol. So dog will also inherit and cat will also inherit and they will also have their own functions. So this are multiple subclasses will share the common properties and this basically promotes the code reuse and modularity. Now what is fourth? Fourth is basically multiple inheritance. So Java does not support multiple inheritance directly due to the diamond problem, and we will read about it, but it can be achieved using interfaces. What happens in multiple inheritance? Multiple inheritance is basically a single class can inherit properties from multiple interfaces. Now what happens is if a single class is inheriting from two parent classes and both of them have a same name. So what happens if a child does not override that method, it does not give the specific implementation of that method, so it creates a kind of ambiguity like which implementation we are going to like child object should inherit, right? So this is basically the problem that we face in multiple inheritance, and multiple inheritance is basically inheriting from two classes, but the problem is in simple terms that if the two classes have a common method name, so which property should the object inherit creates an ambiguity. So what is the diamond problem? As I stated, the diamond problem arises in languages that allow multiple inheritance with classes. So imagine a scenario where a class inherits from two parent classes that both have a method with the same name. Okay, if the child class does not override this method, it creates ambiguity as to which implementation the child should inherit. So this will lead to confusion and potential conflicts, right? So this is the class animal, this is the class dog, and this is the class cat. So if we try to create a hybrid animal that extends to class like dog and cat, Java will give us an error because this is not supported. Because if we call the sound method, how will it decide which sound method to call, right? Unless and until we override that particular method's implementation in the hybrid animal class. So this is not allowed in Java. So animal class, dog and cat extend from animal, and hybrid animal is trying to extend both the dog and the cat class. Now we have the sound method in dog as well as in cat. So hybrid animal class will ambiguity will be created as to which implementation we should use of the sound method. So how Java resolves this? Java avoids this problem by not allowing multiple inheritance with classes. So what happens is in classes multiple inheritance is not allowed. So multiple inheritance can indirectly be achieved using interfaces. Why? Because in interfaces we do not implement that method, right? So in interfaces, automatically the class will have to implement that method, and since it will implement, so that version of the method will automatically be called. So when a class implement multiple interfaces, it must provide the implementation for the method defined in the interfaces. So since it will have to provide the implementation, this will eliminate the ambiguity since the child class explicitly defined the behavior of the inherited methods. We have an interface cat and dog. Now we have a class hybrid animal that will implement dog and cat, and it will give its own implementation of the sound method, right? So dog.super.sound, it will call the dog.sound, or we can also call cat.sound, or we can also define our custom logic, right? So we can call this. Next is dog and cat. Yeah, this is the diagram basically. So dog and cat are two interfaces, and hybrid animal implements these two interfaces, and indirectly we achieve the multiple inheritance. So achieved using interfaces to avoid ambiguity caused by multiple inheritance combines the benefits of various inheritance types. Fifth is the hybrid inheritance. So hybrid inheritance is a combination of more than one type of inheritance, right? Hybrid means combination. So it can involve both single and multiple inheritance, right? So in Java, hybrid inheritance is achieved by combining classes as well as interfaces. Since we have to involve single and multiple inheritance, we use classes as well as interfaces. Like a class can extend one class and implement two interfaces, so that is a hybrid combination. Since Java doesn't support multiple inheritance with classes, the type of inheritance can only be implemented using interfaces alongside with class inheritance. We have a class animal, we have an interface mammal, and we have an interface pet. So as I said, a class will extend a class animal, this is inheritance, and implement two interfaces, this is multiple inheritance, right? So it will provide implementations of the methods in the interfaces like walk and play, and eat also it can override for the specific implementation. So all these three methods can be called. So as we can see here in the diagram, we have a mammal interface, a pet interface, and a animal class dog. Basically implement these two interfaces. Okay, and this is the animal interface which it inherits. So now what are the advantages of inheritance? It is first is code reusability. It will enable the reuse of existing code, reducing redundancy and effort, because the existing, like the repetitive code is already written in the parent class. So the child classes can directly inherit that code and we do not have to define that code in multiple classes. Ease of maintenance, since we have a centralized functionality, so if we have to make a change in some common method, so that we won't have to like make changes everywhere, we can just make the change once at one place and it would be applicable to all the classes. So we have a class animal, we have dog and cat. So if we need to fix a bug in each class or improve it, we only need to do it in the animal. Correct. So extensibility allows developers to extend functionality without altering existing code. We can add one more animal, right? So that is very simple. We can add a method. We can basically extend the functionality. Dog, cat, right? My animal, or we can create any. In this animal, dog and cat inherit the sleep method. So we can extend the functionality of the sleep method in each of the subclass by overriding it to add a specific behavior for each subclass. So this is an example of extensibility. You do not need to modify the animal class itself, right? We can provide our own specific implementation also. So inheritance makes it easier to add new types of animals with different sleeping behaviors. Next, it supports polymorphism. Polymorphism, it facilitates runtime polymorphism, enabling the dynamic behavior. We have a class animal, dog, and cat. So runtime polymorphism, animal reference and dog object. So my animal.sound will call the dog version of sound. Okay, and my animal.sound for cat will call the cat version of sound. So now is disadvantages of inheritance. It creates coupling, yes, because there is a tightly coupled relationship between classes and parents and their subclasses. So making the changes in parent class will affect all its subclasses. So if we make a change in animals eat method, it could break the functionality in the dog class, right? For example, we have already overridden the method in the dog class, but now we in the animal class we change the return type, so it could potentially break the implementation in the dog class. Next is complexity. So overuse of inheritance can also lead to overly complex and hard to maintain hierarchies. So we have a class animal, we have a class mammal, dog. So these are a lot of hierarchies like 1, 2, 3. We can create as many levels as we want. So in big code bases, if we do it like this, so it becomes quite complex and quite hard to maintain. So this will become quite deep nested level of inheritance may become a bit difficult in larger systems to maintain and require large refactoring. So hence we always think before making any decision, always we think that do we really require this kind of inheritance or do we really require this kind of methodology? Third is reduced flexibility. So a subclass is quite heavily dependent on the implementation of superclass, so which can kind of limit the customization, right? So in this example, the dog and cat classes are both inheriting the sleep method from animals. Suppose we want to make dog sleep in a specific way and cat in sleeping in the another specific way. So we will be forced to modify the sleep method in its parent class animal or override it in its subclass. So this kind of reduces the flexibility because we cannot change or extend the sleep behavior independently for each subclass without affecting the others, right? So inheritance is a fundamental feature. So proper use of inheritance fosters efficient development while avoiding common pitfalls such as overcoupling and unnecessary complexity. Thank you.